What if the force accelerating the universe's expansion is beginning to weaken? For over 2 decades, dark energy has been the invisible hand behind the universe's ever-accelerating expansion. Dark energy is a hypothetical form of energy proposed to explain the accelerating expansion of the universe and is a widely accepted concept in cosmology. But a new study of distant supernovae may be challenging that assumption. In a surprising twist, researchers analyzing light from exploding stars across billions of years have uncovered a subtle but persistent pattern. One that suggests dark energy may not be constant after all. It might be weakening, and if true, will change everything we thought about an expanding universe. Since the late 1990s, cosmologists believe that dark energy made up about 68% of the universe, driving galaxies apart faster and faster over time. The discovery was so profound, it earned the 2011 Nobel Prize in Physics. For years, the standard model of cosmology called lambda CDM rested on the idea that this energy was uniform and unchanging. But a new analysis of hundreds of type Ia supernovae reveals a subtle yet consistent departure from what the standard model predicts. Ia supernovae are stellar explosions that act as cosmic mile markers across the universe. According to this new data, the universe's acceleration may have slowed slightly in the last few billion years. It's not reversing yet, but the implication is clear. Dark energy might be evolving. If true, this would overturn a core assumption in modern physics. The cosmological constant is supposed to be constant, but the new findings suggest it could be a dynamical field instead, a force that changes with time, perhaps tied to the properties of space-time itself or the energy density of the vacuum. It means the fate of the universe could be dramatically different from what we thought. Instead of expanding forever at a faster and faster rate, the universe might be heading toward a much quieter future. If dark energy continues to weaken, the expansion could slow, hit a plateau, or even reverse. Some cosmologists have begun whispering about the possibility of a cosmic slowdown. Others speculate it could lead to a big crunch, where gravity eventually reclaims dominance, pulling the universe back in on itself. That idea was largely abandoned after the discovery of dark energy, but now it's back on the table. If dark energy is weakening, it hints at an entirely new realm of physics. It would mean dark energy isn't just a placeholder in Einstein's equations, it's a physical field with its own rules, maybe even its own particles. Some theorists are drawing connections to quintessence, a hypothetical form of energy that evolves over time and interacts with matter and gravity in subtle ways. Unlike a cosmological constant, quintessence could rise and fall, shift in strength, and even vanish. And if that's the case, we might finally be closing in on one of the biggest mysteries in cosmology. What is dark energy? Until now, it's been treated as a mathematical patch, an unknown that made the equations work. But this weakening trend could be the first sign that dark energy has structure, behavior, and maybe even an origin we can discover. Of course, not everyone is convinced. The observed slowdown is small, and the data is difficult to interpret. Some scientists caution that unknown variables, like dust, calibration errors, or sample bias, could be skewing the results. Others say it's too early to challenge lambda CDM, the model that has matched so many observations for so long. But the tension is building. This supernova data adds to a growing body of evidence suggesting that something fundamental may be missing from our current model of the universe. It reflects other recent discrepancies like the Hubble tension, where different methods produce conflicting results about the rate at which the universe is expanding. There is also the recent discovery by astronomer Indranil Banik that suggests that the Milky Way and our entire galaxy cluster may be near the center of a gigantic black void that may also be distorting the data. A subject that we explored and featured in a recent video. If dark energy really is changing, then the story of the universe isn't a simple one-way trajectory into cold, empty expansion. It's dynamic, unfinished, possibly reversible. The universe may not be racing toward a dark eternity after all. It may be stalling. And if that's true, what we thought we knew about an expanding universe may need to be rewritten.